Alright, here are the solutions to the quadratic functions practice test. If you just want to check your answers, just skip ahead to the end of the video and they will all be there. And I'm going to go ahead and start working them 1 through 20 in order. So number 1, we're going to use AFM because it is solved for 0, and we're going to multiply. So 1 times negative 36 is negative 36. And they add up to our middle term of negative 5. And what two factors? I'm looking at 9 and 4 will multiply to negative 36. And the negative has to be with 9. And then I'm looking to see if I have a lead coefficient. I don't. So I'm just going to bring those down and get x minus 9 and x plus 4. I set them both equal to 0, and that would be x minus 9 equals 0, and x plus 4 equal to 0. Add 9, subtract 4, and our two solutions are going to be positive 9 and negative 4. I'm going to put those in set brackets, and that solves number 1. Okay, number 2. Number 2 is set equal to 0, that's good. And I'm looking there and I see that both of those are perfect squares. So that's called difference of squares, when you can just take the square root of each term. And in parentheses you can put your two solutions there, or two factors. The square root of 9 is 3, the square root of w squared is w, the square root of 36 is 6. So I just write 3w and 6 twice. And one of them is going to be a positive, the other is going to be a negative. And the reason I know that's because a positive 6 times a negative 6 gives me a negative 36. So I can always use the box method to multiply those back out to make sure I get that. And I set them both equal to 0, and I'll get 3w plus 6 equal to 0. It's a two-step equation. Subtract 6. And 3w equals negative 6. So I divide by 3, and w would be negative 2. Now I know if that one's negative 2, I know the other one is going to be positive 2. If you're not sure, you can always work those out, but on the difference of squares, they're always going to be like that. So negative 2 and positive 2 are my two solutions for number 2. Alright, on to number 3. We have this one's not set equal to 0, so I need to make sure that that 4 is going to go away, so I'm going to do a minus 4 to both sides. And notice I'm doing it to my like terms. So minus 4 will make that equal to 0, and then negative 17 minus 4 is negative 21. And I just bring down everything else, so 2x squared plus 11x minus 21 equals 0. Now I can try AFM. So I'm going to multiply my outside numbers together, and 2 times negative 21 gives me negative 42. And then bring down my positive 11. What are my two factors in negative 42 that add up to 11? And I came up with 14 and 3. Now one of them needs to be negative, because we're multiplying to get a negative number, and since that's a positive 11, 14 times negative 3 is negative 42, and 14 plus negative 3 is positive 11. So that works. And since I have a lead coefficient other than 1, I need to put both of these over that lead coefficient. And I'm going to simplify them too. So 14 over 2 is just 7. So that one would be x plus 7. Now the other one, that bottom number tells me the coefficient for our x. That's really a 2x there on the bottom. So 2x minus 3, and I set both of those equal to 0, and x plus 7 equal to 0, and 2x minus 3 equal to 0. And solving those, I get minus 7, so that would be negative 7 for my first solution. Add 3, and then divide by 2. And that would give us 3 halves, or 1 1/2. Whoops. And you can just leave it as an improper if you want, so that would be 3/2. So -7 and 3/2. Alright, moving on to number 4. It's not set equal to 0, so again, I want to combine my like terms. So -23, I'm going to do that deliberately over there to the 5. So these are going to cancel out. That's 0, which is what we want. And 5 minus 23 is -18. I'm going to bring down everything else. So I get x squared minus 3x minus 18 equals 0. And now I'm going to use AFM. So I'm going to multiply my outside term. So 1 times -18 is -18. Bring down my middle term of -3. And then what multiplies to give me -18 and adds to -3? I'm thinking of 6 and 3 right now. And which one needs to be negative? The 6. And my lead coefficient's 1, so I don't need to do anything there. So it would just be x minus 6 and x plus 3. Set those both equal to 0, and then it's just as simple as it's the opposite sign, because x minus 6 equals 0, x plus 3 equals 0. We're going to add 6 and add 6, and subtract 3, and we get -3 and positive 6. Put those in set brackets, and we have number 4. Okay, on to number 5. Right, this says using the quadratic formula. So we're going to do A, B, C, and I'm going to write that formula down. It's -b plus or minus square root of b squared minus 4ac over 2a. And remember, we have the Pop Goes the Weasel song to remember that. And I'm going to plug in my values. So it's -b, so since my b is positive 4, I'm going to put a -4 there. Plus or minus square root of 4 squared minus 4 times a, which is 1, times c, which is -12, all over 2a, so over 2 times 1. And I'm going to do order of operations first. So inside of my square root there, I'm going to do my exponent. So it's going to be -4 plus or minus square root of 16. And then a -4 times a -12 is a positive. So I know that's going to be positive 48. So it's plus 48. And then all over 2. So that would be -4 plus or minus square root of 48 plus 16 is 58, 64, which is a perfect square. So over 2. So that'll be -4 plus or minus 8 over 2. And then -4 plus 8 is 4 over 2. -4 minus 8 is -12 over 2. So those are my two solutions, and those both reduce to, I'm going to put that in red at the very top. -12 divided by 2 is -6. 4 divided by 2 is 2. So those are my two solutions. Alright, number 6, you'll notice, is not set equal to 0, so I'm going to do -4 minus 4, and that'll be x squared minus 6x minus 4 equals 0. Now I can do quadratic formula, so I call my A, my B, and my C, and then -b, so since that's already a negative, my B is already negative, that's going to make that a positive 6. So you're just taking the opposite sign of it since you're negating it. And then b squared, anytime I square that b term, it's always going to be positive, even if it's a negative, because a negative times a negative is a positive, and a positive times a positive is a positive. And then I do -4 times 1 times -4. All over 2a, so all over 2 times 1. And then I just simplify using order of operations. So inside of my square root here, I'm going to do exponents, and then I'm going to multiply. So 6 plus or minus square root of 36 minus 4 parentheses 1 -4, And now I'm looking at that, I want to multiply next. So negative 4 times a negative 4 is a positive 16. So that's going to be 6 plus or minus square root of 36 minus 16 all over 2. And that one I'm going to scroll down for. That gives me 36 minus 16 is the square root of 20. So that would be 6 plus or minus the square root of 20 over 2. And I'm going to do the square root of 20 off to the side. I'm going to factor it down, so 5 and 4 and then 2 and 2. We have a pair of 2's, if prime underline. So that's really 6 plus or minus the square root of, 2's on the outside. 2 broke out. So 2 square root of 5 all over 2. And next up, we can do 6 plus 2 square root of 5 over 2, or 6 minus 2 square root of 5 all over 2. Now, do you see something that both of those numbers have in common? I'm seeing the 6 and the 2 and the 2, that I can factor out a 2 from those. So 2 will go into 6 3 times, 2 will go into 2 1 time, so that's just square root of 5. And then those 2's are going to cancel. Same thing here. They all have a 2 in common. So if you factor out a 2, you would get 3 minus square root of 5 all over 2. The 2's cancel. So it's just 3 plus the square root of 5 and 3 minus the square root of 5. All in set brackets. And you can leave it just like that since we don't have a calculator. Now I'm going to scroll back up and put that at the top. Plus square root of 5, 3 minus square root of 5. So they won't always be perfect squares like they were in number 5. So be ready for that. All right, number 7. It says simplify using the given operation. Well, this one doesn't have any operation in between the parentheses, so that tells us we are multiplying. All right, so we are multiplying for number 7. So I can either use FOIL or I can use the box method. I'm going to use the box method. So x squared minus 4x plus 7. That's going to give me 3 rows. And then I'm going to write x minus 9 on top for my columns. And then x squared times x gives me x to the 3rd power. Just adding the exponents when you multiply. And negative 4x times x gives me negative 4x squared. 7 times x is 7x. X squared times negative 9 is negative 9x squared. Negative 4x times negative 9 is 36x. And 7 times negative 9 is negative 63. Remember, the cool thing about the box method is your diagonals are normally going to be like terms. So there's my x squared terms, and there are my x terms. So I'm just going to add those up, and I'm going to get, let's see here, x to the 3rd, and then negative 4 minus 9 is negative 13x squared. 7x plus 36x is 43x. And then just bring down your minus 63 and you're done. Now number 8, you may be tempted to do the same thing, but number 8 has a what? A minus sign. So we are not multiplying here, we're subtracting. So I'm going to distribute that minus sign to all 3 terms over here. Really, I'm just multiplying them by negative 1. So I'm going to bring down the first set. So it's 3x squared minus 8x plus 9. I don't do anything to those, but I'm not going to negate all my 3 terms on the right. So if they're positive, I'm going to make them negative, like that 2x is positive, so that becomes minus 2x. The negative 4x squared is negative, so if I multiply it by negative 1, that makes it positive 4x squared. and a negative 1 times negative 7 is a plus 7. Now I'm going to box and circle my like terms, so 3x squared and plus 4x squared. I'm going to circle the negative 8x, and that's going to be grouped with the negative 2x. And I'll put a triangle around the plus 9 and a triangle around the plus 7. So I get 3x squared plus 4x squared is 7x squared. Negative 8x minus 10x is negative 10x. And 9 plus 7 is positive 16. And I'm done. And again, you can mark those off as you go to keep track of them. And as soon as they're all marked off, you know you are complete. All right, let's go ahead and look at that challenge we have. All right, the challenge wants the similarities and differences, and we're not using a calculator. So I'm going to look at that, and two things I'm looking at are going to be my y-intercept, and I'm also going to look at my lead coefficient. So the y-intercept right off, that should be the easy one. It's just your constant term. So if you plugged in 0 for x, you would just be left with that constant term. So we're comparing these two. So I'm going to call this my first equation, and this is my second equation. And when I do that, I'm going to say for the y-intercept, the first equation has a y-intercept of negative 3. You could say it's graphed at down 3 from the origin. And the second equation has a y-intercept of positive 3. So that's one key difference I see right away. And I noticed that I left out on that question, that should be a squared there. Sorry about that. They do both have a squared, so that's negative 1/4 x squared. All right, moving on. Something else that's different about them, the lead coefficient. The first has a smaller lead coefficient, so we would say the first is going to be wider, because that, actually it's not. The first is going to be narrower. The first is narrower because it is a coefficient of a 1. The other one has a coefficient of negative 1/4. So the 1 is going to, it's a bigger number, so the bigger numbers are going to change more steeply, so that means it's going to be narrower. And the second is wider, because it's a small number, it's negative 1/4, that's a small lead coefficient. So that's going to be a slow change over time. Alright, something else about them. The first one has a positive lead coefficient. What does that tell us? It's going to open, do you remember? So the first one opens up. And the second one opens down. Now we've said a bunch of differences. Are there any similarities? You could say they're both quadratics. How do I know that? They both have a lead coefficient of, they both have an x squared term. Since they both have an x squared term, they're both quadratics. Neither of these are going to be linear. And the last part of this question says, which function can represent an object being thrown into the air? For that one, I would say the second function, and the reason is because it would look like this. So, and remember the x-axis can act as the ground, so it's being thrown up in the air and then it comes back down and hits the ground. So it's because the lead coefficient is negative. So you could explain that in your own words, but that's the visual part of that. Lead coefficient is negative. Alright, that's a challenge. It could be a bonus on your test. Let's move on to the next one. Okay, graph each quadratic function below by hand. Here the y-intercept is just that plus 3. So that would be 0, 3, or you could just say 3 for that. The axis of symmetry is negative b over 2a. So my b is 2, so that would be negative 2 over 2 times negative 1. That would be negative 2 over negative 4. Negative 2 over negative 4 is just 1/2. So that's my axis of symmetry. Oops. Positive 1/2. The vertex, I'm going to plug in the 1/2 by hand, and that would be negative parentheses 1/2 squared plus 2 parentheses 1/2 plus 3. So using order of operations, I do parentheses first and then exponents. So 1/2 squared is 1/4, and then that becomes a negative 1/4 because of the sign in front of it. 2 times 1/2 is 1 whole, so plus 1 plus 3. So adding those up, the first one's going to be 3/4, because that's really like 1 becomes 4/4. So negative 1 plus 4 is 3/4, plus 3 is 3 3/4. So my vertex is going to be that axis of symmetry for my x value, and that 3 3/4 for my y value. And that's always expressed as an ordered pair. Alright, on that next piece we have the zeros, and the zeros, what I'm going to do is set this equal to 0, so it's going to be negative x squared plus 2x plus 3 equal to 0. And I don't like that negative lead coefficient, so I'm going to factor out, this is huge, factor out that negative 1, so this will come out right. If you don't do it this way, you can just do the quadratic formula, but I want to factor out the negative 1 and see if I can just use AFM to factor them. So if I factor out a negative 1, it just changes all of those signs. So that becomes x squared minus 2x minus 3. And then I can simply just ignore that negative 1 because it doesn't have an x, so it's not going to be useful right now. So use AFM. 1 times negative 3 is negative 3. Bring down the negative 2. And then I know that a negative 3 times a positive 1 will work. It adds up to negative 2 and it multiplies to negative 3. My lead coefficient's 1, so I'm done there. And that would just be x minus 3 and x plus 1. Set them both equal to 0. And that would be a positive 3 and a negative 1 for my two solutions. So what does that mean? Well, it means it crosses the x-axis at negative 1 and positive 3. So now when I go to graph it, I can graph a negative 1, and this isn't going to be right on. I'm having a little trouble with the iPad right now. That's pretty close. So that's my zeros. My y-intercept's 0, 3, so I go up to 3. And my axis of symmetry is 1/2. So at half, I'm going to put a dotted line. Again, this isn't perfect, but that's supposed to be a dotted line showing where the vertex is. And if I graph that vertex at 1/2, 3 3/4, that's going to be about right there. And then you're just going to connect your points. Right? So again, don't look at the iPad, the picture too closely. Just look at your points that we calculated from here, and you can graph them a little more exact on your paper. Alright, let's jump over to the next one, number 10. Alright, the y-intercept's negative 8, so I could put 0, negative 8 for that one. Axis of symmetry is negative b over 2a, so it would be negative 2 over 2, which is just negative 1. So I put negative 1 here. Vertex, I plug that back in for my x. So it would be y equals negative 1 in parentheses squared plus 2 times negative 1 minus 8. So do order of operations. We get y equals a negative times a negative is a positive. 2 times negative 1 is negative 2 minus 8. 1 minus negative 2 is negative 1. Negative 1 minus 8 is negative 9. So that's my y value. My x value is negative 1 for my axis of symmetry, so that becomes negative 1, negative 9. And then lastly, for my zeros, I want to see if I can use AFM. If not, I have to use the quadratic formula. So x squared plus 2x, x squared plus 2x minus 8, I set it equal to 0. And I'm going to multiply there, and 1 times negative 8 is negative 8, bring down my 2, and I'm thinking 4 and 2, one of them needs to be negative, so the 2 has to be negative. Lead coefficient's 1, so it's just x plus 4 and x minus 2. And set those equal to 0, it's going to just change their signs for that, so it would be negative 4 and positive 2 would be my two zeros. So that's where it crosses the x-axis. So now I'm going to graph those. I'll graph them in red. Again, this isn't going to be exact, but negative 4 and 2, those are my zeros I just graphed. The y-intercept 0, negative 8. I think that goes down to 10, so that's probably about right there. Axis of symmetry is negative 1, so that means at x equals negative 1, I have a dotted line showing where that vertex is. That's where you can fold the graph over in half. It's symmetrical. And then the vertex is negative 1, negative 9. So I go left 1, down 9. It's going to be somewhere about there. And then I just connect all these, making my quadratic, go through the existing points that you have, and it should look something like that. Alright, that sums it up for 10. Okay, number 11, we want to find our y-intercept, which is 3, so 0, 3. Axis of symmetry is negative b over 2a, so that would be negative 2 over negative 2 times 1, which is negative 2, which would be positive 1. And then my vertex, plug that 1 back in, and it will be negative, y equals negative parentheses 1 squared plus 2 parentheses 1 plus 3. And 1 squared is 1, and then I bring down the negative, so that's really a negative 1. And then plus 2 plus 3. Negative 1 plus 2 is 1. 1 plus 3 is 4, so y equals 4. So for my vertex, write the ordered pair. So the axis of symmetry comes first, so it's 1, 4. And then for my zeros, I use AFM if I can. Let's see if I can for this one. So it was negative x squared plus 2x plus 3 equal to 0. And I'm just going to factor out a negative 1 because I don't like that lead coefficient being negative, and that's going to change all of these signs. And then I'm just going to ignore that negative 1 since it doesn't have an x. It's not going to help me out with the solution. So let's get negative 3, negative 2. Are there any factors of negative 3 that add up to negative 2? Yeah, negative 3 and 1 works. They multiply to give me negative 3. They add to give me negative 2. Lead coefficient's 1, so I just write x minus 3 and x plus 1. And those set equal to 0 just changes the sign. So it'd be 3 and negative 1. And then I'm just going to graph them. So 0, 3 is my y-intercept. Axis of symmetry is 1. Vertex is 1, 4. Somewhere about right around there. Negative 1, 3. Negative 1 is where it crosses the x-axis. 3 is where it crosses the x-axis. And again, my axis of symmetry is that dotted line. So that would be at 1. And then I'm just going to draw my quadratic through those points. And that's what I have for number 11. Alright, that's going to end it for this video, and I'm going to scroll back and you can check your answers. So number 1, negative 4, 9. Number 2 is negative 2 and 2. Number 3 is negative 7 and 3/2. Number 4 is negative 3 and 6. Number 5, we got negative 6 and 2. Number 6, 3 plus square root of 5 and 3 minus square root of 5. Number 7, if I can scroll up, 7 is written at the top there. 8 is 7x